looking at work, which is the amount of energy that is used to move something. Power is the rate that work is done at. Rate is always a relationship between two things. And so we're given two different ways of calculating power. We can look at work over time, or we can look at the change in energy over time. And when we're looking at the change in energy, we're looking at an initial and then a final value. Okay? So the example given is a light bulb. If the box always displays how many watts that the light bulb is, so a 60 watt or a 100 watt or a 30 watt light bulb, it just means that a watt is that it's using 60 joules of energy every second. So time is still measured in seconds, energy is always measured in joules, and the new unit that's being given to us is a watt. Okay? Power is scalar, work is scalar. So let's just jump right into the math. A 60 kilogram student runs at a constant velocity up a 4-meter incline that is at an angle of 40 degrees in 4.5 seconds. Calculate the power output by the student. Let's start by drawing a picture. Oh, I have the hiccups. Drawing a picture and a pen that works. So here's our incline. It says that the incline is 4 meters and that it's at an angle of 40 degrees. Okay? And so the 60 kilogram student is running up the incline. So that's our direction of motion, is up the incline. It says calculate the power output by the student. Our list of knowns So in order to calculate power, we have two formulas that we can look at. We can look at power is equal to work over time, or we can look at the change in energy over time. Are we given work? No. Are we given force? Because we can solve work by force times distance. We're not given force, so there's too many unknowns to use that particular formula. If I look at the change in energy one, the student is running at a constant velocity. That's the other key here. If it's a constant velocity, is there a force applied? No, because there's no acceleration, right? You have to have acceleration to have a force applied. So what we can look at, because he's going up an incline, we have a height here. So what formula when we're talking about energy has height in it? Energy H? Oh, MGH. I'm like, what is energy H? I don't know that one. What energy though are we looking at that uses MGH? Potential energy. So we're going to have potential energy final minus potential energy initial. Now, is there initial potential energy? No, because this student is running. So there's no initial potential energy. So final, we can solve using MGH. We have M, it's a 60 kilogram student. G is gravity, 9.81. And H we can calculate using what math function? We have a hypotenuse and an angle. So we could use trig to find h. Okay? So h, is h adjacent or opposite the angle? So we're going to go the sine of 40 times our hypotenuse, which is 4. And we get what for a value? Okay, and it's going to be in meters. Boy, I had myself fooled for a minute there. Okay, so change in energy then is going to be 60 kilograms multiplied by 9.81 multiplied by 2.5711, and you're going to use all your decimals. And what is our change in energy? Okay, so 1500 joules is what our change in energy is. Now we can go back to the original formula. Yes, sir. Can I move the paper? Sure, I can move the paper. Okay, so we're going to get 1513.397. You're going to use all your decimals. And we're going to divide it by the 4.5 seconds. For our power to be equal to, okay, and our new unit to us is a watt. And when we look at a watt is energy is measured in joules and time is measured in seconds. So a watt is a joule per second. That's the base units. Just like a Newton is made up of kilograms meters per second squared, right? Mass times acceleration. A watt is made up of energy divided by time. So joules per second is what a watt represents. Go back to the original question, and our sig digs is 2. 1, 2. So the 6 will play on the 3. 3.4 times 10 to the power of 2 watts. It's scalar. We don't need a direction on it. Okay? Questions? It's going to always come down to what information does the question provide to you, which formula you're going to use. And sometimes, yes, you will have to think outside the box of how do I get either one of those things. Okay, a 1,000 kilogram car accelerates from rest. That's code word for VI is equal to 0. To a velocity of 15 meters per second in 4.00 seconds. Calculate the power output in the car in 4 seconds. So mass, writing down our knowns. And then our time. Okay, it's asking us to find power. 2 ways to find power: work over time or change in energy over time. Is work given to us? Work is made up of force and distance. Are either one of those given to us? No. So we're not going to use this particular method. We're going to use the change in energy over time. Now, this vehicle goes from 0 to 15 meters per second. What kind of energy are we looking at? We got two. We got potential and kinetic. Kinetic, because it's in motion, right? So the change in energy is going to be equal to EKF minus EKI. Now, at initial, what was the velocity? Anything multiplied by 0 is going to be 0. How do I find EKF? 1/2 mv squared. So 1/2 I'm going to say this again, and it's going to sound like I'm beating a dead horse, but I just marked everything that was turned in, and a lot of people write down that they should square something and then don't actually square it when they do the calculation. So highlight those pieces. If you have to square root, highlight the square root in your math so you don't forget to do it. EKF equals okay. So that's our change in energy. So then we can say that power is equal to change in energy over time. And so we got 112,500 joules. I'm just going to write a little side note here. Divided by 4.00 seconds. Power then becomes equal to okay, joules per second. Let's go back to the question for significant digits. 3. 1, 2, 3. So it's the 2 that's going to play onto the 1. So we're going to have 2.81 times 10 to the power of what? 4. And a joules per second is also called a watt. Okay. Writing down your knowns and picking those pieces out, those code words out from REST, those are going to be crucial in being able to solve problems. Okay. A 200 watt motor is being used to lift shingles at a constant velocity to the top of a roof. If one pack of shingles has a 28 kilogram mass, determine the speed the pack will be raised at. Okay, so this is our house. And I don't know if you've ever watched anybody shingle anything, but they usually like either forklift it or put a ladder up here and they pack shingle bundles up onto the roof. It's asking us to determine the speed. What is the easiest way to solve for speed? How much? Distance over time. Okay, we're not going to reinvent the wheel. Now, we have no time. And we have no distance. So how are we going to solve all of this stuff when we're missing all kinds of information? When we look at the flow chart, so how would we solve for distance? Work is equal to force times distance times cos theta. That's the best that we can do right now in this unit. I mean, there's a multitude of ways of solving for it, but we don't have distance, we don't have acceleration, and we don't have time, we don't have a VF or a VI. We're not going that way. How would we solve for, this would be what we're looking for, Force is force net is equal to force applied minus force of gravity. Force net would be 0 because it's at a constant velocity, right? Keywords in the question. So we could say then that force applied is equal to force gravity, and then force gravity would be mass times gravity. We do have mass, so we could get that side of it covered. Cos theta is equal to 1 because theta is 0 degrees. It's parallel. We're going up the house in the same direction. So we got that. We can do force, we can do cos theta. However, we don't have work. So there's an unknown there. We know that we can get time from power is equal to work over time. But we don't have time in the question. We don't have power in the question. So we're at a bit of a stalemate. So I'm going to write this down. So the flow chart still ends up with unknowns in each equation. So what we're going to do is we're going to take our knowledge of mathing and we're going to jump it up 1,000 notches. We're going to do substitution of formulas. Okay? So we know that if I was to solve for, what's the unknown here that we don't have? Work. So let's take this formula here and solve for work. Work is equal to power times time. Okay? What we could then do is we could then substitute into the work is equal to force distance cos theta formula. And so what we would have is we would have PT, because that's what we said work is equal to force distance. Up here we say cos theta is 1. So I'm just going to put 1 here. Okay. Now, what is the other piece of information that we don't have out of all of this that we said up here was missing? Distance. Okay, let's solve for distance. PT over F is equal to distance. Okay, now we're going to put that back into our velocity is equal to distance over time formula. So velocity then would be equal to, we said distance is equal to PT over F divided by time. Do we have P in the question? Yes. Do we have time in the question? Okay. Do we have force? We can get it from mass times gravity. So when we look at this, let's just rewrite this. Velocity is equal to PT over FT. I just, instead of having 1 over something, I just put it so that it's 1 over something. What do we see happens to time? Cancels out. So now are we worried about time? No. Velocity is going to be equal to power over, and we just said that force is calculated through mass times gravity. Is that the answer I heard? Okay. So then if we had to give an actual sig-dig answer, it would be 0.73 meters per second. And it said speed, so we don't need a direction. Okay. Let's not stop there. Let's prove that we can get velocity from power over mgh. Power is measured by what unit? A watt per. Mass is measured by kilograms. And gravity is measured by meters per second squared. Okay, a watt is a joule per second, kilograms, meters per second squared. A joule is what? Let's look. A joule measures energy, right? And the formula for an energy is 1/2 times kilograms times meters per second squared, which means that a joule is a kilogram meter squared per second squared. That's what a joule is. So here I have kilograms meter squared per second squared per kilograms meters per second squared multiplied by this second. Okay? This second here is this second here. So my kilograms are going to cancel out. My kilograms are going to cancel out. And my meter here is going to cancel out one of those guys here. And my second squared is going to cancel out this second squared down here. And so I'm left with meters per second. So unit analysis, that's what this is called. Unit analysis proves that velocity can be determined by power over force of gravity. Okay? This is as complicated a question as you can get. And I would never ever test you on your ability to do these multiple substitutions. But we see that in Physics 30. And so I'm introducing it to you now. Okay? Questions, comments, concerns? It's a lot. This is an incredibly hard question. So I'm okay if you've got a thumbs down on this particular question. Let's look at practice problems before we move on.